All right, guys, let's get into some more piecewise functions. These are just special ones. Starting out with what's called a step function. So if you take a look at the graph here, we can see that this is like a cell phone, or yeah, a cell phone through Xfinity Mobile, which I actually use. And they offer plans that cost $12 per gig. Okay, or there's an unlimited plan for $45. So here's a look at the graph. We can see on the bottom the X values are the number of gigs used, and then of course your total cost on the y-axis there. So for example, if you use less than 1 gig, you can see that your cost will be $12. But as soon as you get past 1 gig, it goes up to $24. As soon as you go past 2, it goes up to $36, and then once you get past 3, it's just going to be a straight $45 unlimited package. So can we write a piecewise function to determine the cost? So again, take this graph and let's turn it into a piecewise function. Okay, it looks like there's going to be a few pieces on there. Let me just erase this so we have a little space. All right, so the f of x, okay, is going to equal, so let's talk about this first piece here. Let's say that piece right there. Okay, so the y value equals 12 for x values that are greater than 0 and all the way up to 1. Okay, so the domain restriction would be 0 is less than x, which is less than or equal to 1. Okay, so technically if you use exactly 1 gig, it's going to be $12. But then as soon as you go past 1, you can see it's going to jump up to $24. So that's why we have an open circle right here, because when x actually equals 1, we're paying the $12 amount, not the $24 amount. Okay, so the next function rule will be that the y value or the cost is $24 when x, okay, when 1 is less than x, but x is less than or equal to 2. Okay, in other words, if you use between 1 and 2 gigs, including 2. The third piece then we see is $36, and that rule applies for all x values that are greater than or equal to 2, but less than or equal to 3. And then finally, the final piece, you're paying the $45 fee if your amount of data used is anything greater than 3. You would just pay the unlimited price. Okay, so hopefully we can see the piecewise. Let's color code everything here. So there's the black piece. Okay, so this is really just a piecewise function. And again, when the y values are all just constant numbers, okay, there's no x involved there. It's just a constant number. That just makes this be referred to as a step function. Okay, and hopefully you can kind of look at the graph and see how it kind of looks like steps. Okay, so that's a special type of piecewise function right there. All right, so getting into the textbook here, page 61, let's see if we can graph step functions, and then we'll get into some absolute value functions as well. So number 1 here, they give us a step function. Let's see if we can piece together the graph. All right, so I see that f of x equals -2 if x is less than -3, and then f of x will equal 1 for the x values between -3 and 2, and then it will equal 3 if x is greater than or equal to 2. Okay, so what I'm going to do, just to set this up, I'm going to look at these restrictions over here first, and I'm just going to set up like borderlines or whatever. So when x is -3, 1, 2, 3, okay, this is the line x equals -3. Then there's another rule when x is between -3 and 2. Okay, and then there's another rule on the right. So we kind of created 3 regions on the graph. And again, this is just for our own kind of organization. But let's go ahead and plot the functions. So the y value is -2 if x is less than -3. So the y value is -2. I do need to do an open circle there and go that way. Okay, that's showing y values are -2 when the x's are less than -3. So there's one step or one piece. The middle piece, the y value needs to equal 1 when x is between -3. So the y value is 1 all the way till x being less than 2. So open circle there again because it doesn't have the equal sign. Because when x actually equals 3, or I'm sorry, when x actually equals 2, our y value needs to be 3. So 1, 2, 3. There's the closed circle. and that's our y value for all the points to the right of 2. Okay, so there is a piecewise function that is a special one, right? It's a step function because it just had constant values. And again, hopefully we see why it's called a step function. You get those flat kind of stairs. All right, let's move along a little bit here. Let's take a look at this example. This one, they're giving us a different type of piecewise function. Here's the rule. So f of x equals negative x if x is less than 0. And then f of x equals x if x is greater than or equal to 0. So let's fill in a little table of values. And again, you could always graph these just knowing slopes and y-intercepts like we kind of did in the first section. But let's just use the table and see what happens. So first rule, f of x equals the opposite of x for x's that are less than 0. So for these three values, right, those x's are less than 0, it's telling me the y value is just the opposite of the x value. So negative 3 becomes positive 3. Negative 2 becomes positive 2, and negative 1 becomes 1. And now for these, if x is greater than or equal to 0, right, which is all these values, the f of x value just equals the x value. Okay, so let's plot those. Let's see what we got going on here, okay? So negative 3, 3, negative 2, 2, negative 1, 1, 0, 0. Looks kind of linear, right? It looks just like a negative slope, like it should. But then the other piece now should have a positive slope, right? So 0, 0, 1, 1, 2, 2, 3, 3. Okay, and we actually get this, looks like a V, right? And we would expect the pattern would continue, and it would. Okay, so that's what the graph looks like. Okay, this should remind you of something. Think about when you take a negative number and it becomes positive, but the positive numbers stay the same. Okay, does that remind us of anything? Anything else on that page that we missed? Nope. Okay. Let's come back to that. So let's think about what that is. So again, the graph, just we can have a sketch of it and then answer these questions about it. So it looks like 1, 2, 3, 1, 2, 3. I guess I could use the graph paper that's right there. But, the graph did something like, all right, so we had that V. Okay, so let's think about domain and range of the function here. Okay, so domain and range of the function. So the domain again, which x values is this thing going to exist for? Okay, if you think about the way the rule was written, we had one rule for all negative x values. We had one rule for all numbers greater than or equal to 0. So the domain is going to be all real numbers, right? X could be anything we wanted. But the range, okay, if you take a look at this graph again, range, think about, is there a minimum or is there a maximum y value, or does it just go up and down forever? And for me, I think this point 0, 0 here is a minimum. So the range would be all y values that are greater than or equal to 0. Okay, and just to review, writing those in interval notation, all reals is negative infinity to infinity. And greater than or equal to 0, we have to use a square bracket because we're going to include 0. So 0 to infinity. All right, does the function have a minimum or maximum value? We talked about that when we talked about the range. It has a minimum value, okay, and the minimum value is y equals 0. When we talk minimums and maximums, we're talking about the y value, and it just so happens to occur at x equals 0. But the actual minimum itself is because the y value is 0. Okay, part C, what are the x-intercepts and y-intercepts? They are both 0, right? It crosses at the origin. And does this thing seem to have any symmetry? Okay, is there like a line of symmetry? And there actually is, right? Right down the middle here. Right down the line x equals 0. Okay, or the y-axis would be a line of symmetry on there, right? It's kind of the same on both sides, right? It's like kind of looking in a mirror. So pretty cool. All right, so hopefully when I was trying to lead you guys to this function that we were looking at, that's known as the absolute value function. Isn't that exactly what absolute value does? Like if you have a negative number and you take the absolute value of it, it becomes positive. right? But if the number's already positive, then the absolute value just keeps it the same. That was the rule that we used, right? That's the rule we can see right here. So let's use the definition, use the piecewise function number 8 here to evaluate each expression. So what would f of negative 14 be, right? So since the x value is negative, the absolute value says take the opposite. So f of negative 14, okay, or the absolute value of negative 14 is 14. Part B, the absolute value of 8 is 8. Absolute value of 0 is 0. All right, now what in the heck's going on in part D? F of 2 minus root 5. So let's see, is 2 minus root 5, is that positive or is it negative? So root 5 is bigger than 2, right? So this is going to be a negative number. So all that tells us, I don't even really care what the answer is, since the x value is less than 0, I know that the y value will just be the opposite of the x value. Okay, so it's just negative 2 minus root 5, whatever that is. Again, calculator, you need a calculator to do that. Okay, so what we were doing there, we were finding the absolute value of the function, and that's kind of, I think, what number 9 is asking about. Could we have found these any other way? And sure, we could have. But yeah, so that's kind of what's going on there. That's the absolute value function. It is just a special piecewise function. So that's what this section was all about, right? Different types of piecewise functions. There's step functions, which we saw when you have constant flat pieces. And then the absolute value is another special one. Okay, so the assignment to practice today, you'll see on page 64, numbers 14 through 19. That first one, read through, is going to be a step function similar to the one we did at the beginning with the Xfinity mobile pricing. All right,